We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Godspeed, John Glenn.
Roger, 0G, and I feel fine.
Getting my feet out. Okay, I'm out.
How does it feel for the United States to be the new record holder?
At last, huh? When that baby lights, there's no doubt about it.
Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Houston, Tranquility Base here. The Eagle has landed.
That's one small step for man, one giant leap for mankind.
Hello and welcome. This is Michael Annis, and you're listening to episode 102 of the Space Rocket History Podcast. And now, Apollo Preliminary Design, Part 3. Recapping from episode 101, the first serious studies of mode began. By that I mean the method that Apollo would use to land on the moon. Direct descent, Earth orbit rendezvous, or lunar orbit rendezvous. Resolving the mode question would become the most difficult decision of the entire Apollo program. A consensus developed on the 6 areas in which major contracts would be needed. First, launch vehicles. Second, the spacecraft command module, which would double as the return vehicle. Third, the propulsion module with extra duty as the lunar takeoff section. Fourth, the lunar landing stage, which would be both a braking rocket and a lunar launch pad. Fifth, the communications and tracking network. And sixth, the Earth launch facilities. In order to get these projects underway, Gilruth was given approval to release the spacecraft development contract. The Space Task Group decided to pursue a blunt body design for the command module as opposed to a lifting body, and MIT's Instrumentation Laboratory was awarded the first contract for Apollo in astronavigation. The attention devoted to guidance and navigation did not halt preparations for a contract on the command module. Data from the feasibility studies and from Space Task Group's in-house work were used to prepare a statement of work detailing the contractor's responsibility and his scope in designing, building, and testing the spacecraft. Project Apollo would have 4 phases: Earth orbital, circumlunar, lunar orbital, and lunar landing. The prime spacecraft contractor would develop and build the command module, service propulsion module, ground support equipment, the adapter, which was the device used to fit the spacecraft to a space laboratory for Earth orbit flights, and to the lunar landing propulsion section for lunar missions. Although the prime spacecraft contractor would not build the lunar landing module, the company would integrate that system into the complete spacecraft stack and ensure compatibility of the spacecraft with the launch vehicle. Okay, let's talk money for a minute. Just before leaving NASA early in 1961, Administrator Keith Glennon had revised the procedures for the establishment and operation of source evaluation boards. For any NASA contract expected to exceed $1 million, all proposals would have to be evaluated by a source evaluation board. For any contract that might cost over $5 million, proposals would be judged by a special source evaluation board appointed by the Associate Administrator. The board's findings would then be passed to the Administrator himself for final selection. On July 28, 1961, Siemens approved the overall plan for Apollo spacecraft procurement, and he appointed the Source Evaluation Board members who would assess the proposals. Then the Space Task Group issued its request for proposals to 14 aerospace companies. The deadline for the submission of proposals was set for October 9th, giving the prospective bidders more than 10 weeks to work out their proposals. A conference was held on August 14th so NASA could explain the guidelines for the contract in detail. Almost 400 questions were asked at the meeting and answered. The answers were recorded and distributed. Siemens then appointed an 11-man source evaluation board headed by Faget and including one non-voting member from headquarters, James T. Koppenhauer, a reliability expert. The board consisted of 6 voting members from the Space Task Group: Robert Pylon, Wesley Hornevec, Kenneth S. Kleinnick, Charles Matthews, James Chamberlain, and Dave Lang. 1 from Marshall, Oswald Lang, and 2 from headquarters, George Lowe and Albert Claggett. Faget's board directed the technical assessment teams and a business subcommittee to work out and submit a numerical scoring system for comparing the bidders' proposals. On October 9th, 5 hopeful giants of the aerospace industry brought their proposals to the Chamberlain Hotel in Old Port Comfort, Virginia. The companies participating were Martin Company, General Dynamics, North American Aviation, General Electric, and McDonnell Aircraft. During the first 2 days of a 3-day meeting, these documents were distributed among the members of the NASA assessment teams. The massive technical proposals, separated from those on business management and cost, were scrutinized and evaluated by more than 100 specialists. Each group of bidders was then called in on the 3rd day to make an oral presentation and answer questions. Gilruth persistently asked the proposal leaders, "What single problem do your people identify as the most difficult task in getting man to the moon?" The bidders answered the question by stressing the balance between performance, cost, and schedule for such a complex project. Next, the Source Evaluation Board evaluated the proposals and submitted their report on November 24, 1961. The Source Board evaluated each proposal using the numerical scoring system on 3 major categories. The first category was the technical approach the company proposed for the command module. This category counted 30%. Second was the technical qualifications of the company, which also counted 30%. And lastly was the business management of the company, which counted 40%. So, as each bidder was evaluated, they received a score. So logically, the bidder with the highest score would be awarded the contract, right? That makes sense, doesn't it? Well, maybe not. Martin Company got the highest overall score. General Dynamics and North American tied for 2nd place, and General Electric tied with McDonnell for 4th place. This was the Source Evaluation Board's recommendation. Quote, "The Martin Company is considered the outstanding source for the Apollo prime contractor. Martin not only rated first in technical approach, a very close second in technical qualification, and second in business management, but also stood up well under further scrutiny of the board." End quote. However, if Martin were not selected, the board recommended North American as the most desirable alternative. The board wrote, quote, "North American Aviation rated highest of all participants in the major area of technical qualifications. North American's pertinent experience, consisting of the X-15, Navajo, and Hound Dog, coupled with an outstanding performance in the development of manned aircraft such as the F-100 and F-86, resulted in its being the highest rated in this area. The lead personnel proposed by North American showed a strong background in development projects and were judged to be the best of any proposed. Like Martin, North American proposed a project managed by a single prime contractor with subsystems obtained by subcontracting, which also had the good features described for the Martin proposal. North American's project organization, however, did not enjoy quite as strong a position with the corporate structure as Martin's did. The high technical qualifications rating resulting from these features of the proposal was therefore high enough to give North American a rating of second in the total technical evaluation, although its detailed technical approach was assessed as the weakest submitted. The relative weakness might be attributed to the advantage of the McDonnell Aircraft Corporation's Mercury experience and the other three participants' experience on the Apollo study contracts. The Source Evaluation Board is convinced that North American is well qualified to carry out the assignment of Apollo prime contractor, and that the shortcomings in its proposal could be rectified through further design efforts on their part. North American submitted a low-cost estimate, which, however, contained a number of discrepancies. But North American's cost history was evaluated as the best. End quote. At this point, something unfortunate happened. Word leaked out prematurely to Martin Company that it had scored highest in the evaluations. After 2 years of planning and 5 weeks of waiting, the Martin employees were informed over the public address system on November 27, 1961, that they had won the contest to build the moonship. Sadly, the next day they learned the truth. North American was given the spacecraft development contract. Webb, Dryden, and Siemens apparently chose the company with the longest record of close association with the NACA and NASA, and the most straightforward advance into spaceflight. The decision would have to be defended before Congress and would be the cause of some anguish later. When it was announced on November 28th, shouts of joy rang through North American's plant at Downey, California, as John Paup broke the news over the PA system. During December 1961, Space Task Group and North American program directors and engineers met in Williamsburg, Virginia, to lay the technical groundwork for the spacecraft development program and begin contract negotiations. The spacecraft portion of Apollo had entered the hardware phase, although the launch vehicle, or vehicles, and the lunar lander had not. At the same time Gilruth was working with the space development contract, Associate Administrator Siemens realized that it was time to decide what the rest of the Apollo stack should comprise. The method chosen for the lunar trip, rendezvous, or direct descent would affect Apollo's cost and schedules, as well as the launch vehicle configuration. A launch vehicle to support the moon landing was a big question mark when President Kennedy issued his challenge in May of '61. The Space Task Group was not sure how big a vehicle would be needed, so they were hoping NASA would develop the enormous Nova rocket. Marshall wanted to build a big liquid-fueled rocket, but was a little cautious about tackling a vehicle the size of Nova. One aspect that caused Marshall to hold back was the high cost projected for the F-1 engines. But one thing is for sure, they certainly didn't want to use the small rockets available at the time. Here's Werner von Braun commenting on that.
Dr. Kontrowitz, I think I can comment on this. If you remember this figure of 400,000 pounds initial weight needed in orbit to put a crew of 3 men to the moon, you are really talking about something like 100 ICBM launches to put that initial payload together in orbit, and this becomes a logistics problem like flying the Berlin airlift with Piper Cubs. Nobody can say it can't be done, but it is certainly very attractive.
If that were the quickest way of doing it, and we had Piper Cubs, should we wait until we develop DC-6s to do it with?
Well, we think within the total framework of time available here, these 9 years or 8 years that we have, I would put my money on the DC-6s. That's it.
When Max Faget learned of Marshall's misgivings about using the expensive F-1 engines for a Nova rocket, he suggested that solid-fueled rockets be used for the first stage. Faget thought the first stage could consist of 4 solid-fuel engines 6.6 meters in diameter. These could certainly accomplish whatever mission was required of either Saturn or Nova, whichever was chosen, at a reasonable cost. It made good sense, Faget said, to use cheap solid fuels for expendable rockets and more expensive liquid fuels for reusable engines. Faget called the individual solid rockets the Tiger because he thought it would be a noisy animal and would roar like a tiger. But Faget and his group could not sell their idea. Liquids were preferred by both Headquarters and Marshall, who insisted that the solids were too heavy to move from the casting pit to the launch pad. They also argued that solids had poor burning characteristics and were unstable. So the launch vehicle question dragged on. You may recall from the previous episode the mode studies made by the Fleming and then the London Committee. Siemens had these study reports distributed, and he met with several Headquarters program directors to discuss whether the advanced Saturn, which was called the C3, recommended by London's team, could make the voyage to the Moon if the Earth orbital rendezvous approach were chosen. Silverstein warned that the vehicle's upper stages were simply not well enough defined as yet, and Siemens agreed. On June 20th, he asked Colonel Donald H. Heaton to head a task force to study the Saturn C3 and its possible use in the manned lunar landing mission using rendezvous techniques. Colonel Heaton's group followed Fleming's lead in narrowing the scope of its investigation to a single mode, in this case, the Earth orbital rendezvous mode, as a way to go to the Moon. Most of the members agreed that this mode offered the earliest chance for landing. Either the C3 or its next larger version, a C4, could be used. But the team urged that NASA begin work on the C4 because it should offer a higher probability of an earlier successful manned lunar landing than the C3. Moreover, a rendezvous capability would enable the C4 to cope with future payload increases that the direct descent Nova-class booster with its fixed thrust would be unable to handle. On June 22nd, Webb and Dryden met with several of their top lieutenants to see what useful items could be gleaned from the reports of all these committees for charting Apollo's strategy. Abraham Hyatt, the new chief of plans and programs, criticized any plan that required development of 2 launch vehicles, one for circumlunar mission and another for direct flight. Hyatt suggested that NASA either build a huge launch vehicle with as many as 8 F-1 engines in the first stage for both circumlunar flight and lunar landing, or cluster half that number of these engines in a somewhat smaller vehicle and use rendezvous techniques. The meeting produced several significant program decisions. Most important was the order for Marshall to stop work on the C2 and begin preliminary design on the Saturn C3 and continue studies of a much larger vehicle for lunar landing missions. Now, a little bit of technical details about the Saturn C3. It was a 3-stage configuration. The first stage was to use 2 F-1 engines with a combined thrust of 13.3 million newtons, or 3 million pounds. The second stage would have 4 J2 engines with a 3.6 million newton total, or 800,000 pounds of thrust. And the third stage was called S-4, with 4 engines using liquid hydrogen and liquid oxygen propellants, with a 355,000 newton or 80,000-pound total thrust. Another consideration for booster development was to minimize unnecessary duplication among agencies. This necessitated the involvement of the Department of Defense. Early in July 1961, Siemens and John H. Rubel, Assistant Secretary of Defense and Deputy Director of Defense Research and Engineering, agreed on the need for joint NASA defense planning. Siemens informed Webb that the two agencies would try to determine what boosters would best meet the requirements of both the Department of Defense and NASA. The civilian agency's central concern, of course, was a launch vehicle for Apollo. With the approval of both Defense Secretary Robert McNamara and Administrator Webb, Rubel and Siemens set up a DoD-NASA Large Launch Vehicle Planning Group on July 20th. Nicholas Golovin, an applied mathematician and Siemens technical assistant, shared the chair with Lawrence Cavanaugh, a missile expert from the Defense Department. The group soon became known as the Golovin Committee. This committee, like all the others, found that for Apollo, vehicle selection and mode were inseparable. At first, the planners considered only direct descent and Earth orbit rendezvous, but they soon broadened their study to include other kinds of rendezvous. When it became apparent that the committee intended to delve deeply into the mode issue, Harvey Hall of NASA's Office of Launch Vehicle Programs asked that Marshall, Langley, and the Jet Propulsion Laboratory each study one particular kind of rendezvous, Earth orbit, or lunar surface, and prepare a report for the Golovin group. Hall's own office would study direct descent. Gilruth now became concerned that this latest in the series of headquarters committees established to select a launch vehicle for Apollo would also get bogged down in the mode issue. Gilruth wrote a letter to Golovin about the degree to which rendezvous had pervaded recent thinking. In the letter, Gilruth wrote, quote, "I feel that it is highly desirable to develop a launch vehicle with sufficient performance and reliability to carry out the lunar landing mission using the direct approach. I am concerned that rendezvous schemes may be used as a crutch to achieve early planned dates for launch vehicle availability and to avoid the difficulty of developing a reliable Nova-class launch vehicle." End quote. But, just as Gilruth had feared, Golovin's group did get mired in the mode issue, leaving the choice of an Apollo launch vehicle still unsettled. On September 18th, one committee member said the group preferred rendezvous rather than direct flight because smaller vehicles would be available earlier than the larger boosters. Preliminary conclusions indicated that the manned lunar landing might be made with the Saturn C4 more safely than with the Nova. Moreover, the C4 would be more useful to other NASA and Defense Department long-range needs. Now, a few details on the C4. The Saturn C4 was planned to be the next step up from the C3. The booster stage would consist of 4 clustered F1 engines with 26.7 million newtons or 6 million pounds of thrust, and a second stage consisting of 4 J2 engines with a combined thrust of 3.6 million newtons or 800,000 pounds. Now back to Golovin's group. It is interesting to note Golovin himself disagreed with the majority of his group, insisting that direct flight was the safest and best way to go. In fact, Golovin and those of his team who shared his belief talked to Siemens and Rubel about solid-fueled versus liquid-fueled rocket engines for Nova. They also discussed the concept of modules, or building blocks, to achieve a variety of launch vehicles. and an S-4B stage, which could be powered by a single J2 engine. Siemens, realizing that some kind of advanced Saturn seemed inevitable, asked Golovin how many F1 engines should be in the vehicle's first stage. Golovin replied, 4. Anything less is a waste of time. Golovin also recommended that the advanced Saturn be engineered so it could become almost as powerful as the Nova. At the committee's general session on October 23rd and 24th, debates grew hotter over solid versus liquid-fueled engines for the Nova, the size of the huge booster, and the merits of 5 rather than 4 F1 engines in the advanced Saturn's first stage. Heinrich Weigand and Matthew Collins objected strongly to any assumptions that rendezvous in space would be easy. Weigand contended that his fellow committeemen were underestimating the difficulty of rendezvous and docking. He wanted a Nova with large solid-fueled rocket engines in its first stage. Co-chairman Kavanaugh warned that lunar orbit rendezvous or direct descent was the only way to beat the Russians, adding that he believed the Saturn C-4 could do the job either way. Golovin countered that competition with the Russians was a permanent thing. He insisted that both orbital operations and the development of large boosters would have to be studied for at least 2 years before any mode choice was possible. After listening to the co-chairman express his opposing views, Collins asked bluntly, "Are we going to recommend rendezvous or direct flight?" He was then reminded that the mode decision was not in their charter. The committee was supposed to be selecting a launch vehicle to support either rendezvous or direct flight. The group then returned to the arguments over 4 versus 5 engines for the advanced Saturn first stage and the Nova configuration. And there the issues lay. Once again, nothing was settled. Although the October sessions wound up the Golovin Committee meetings, the group's greatest value had been as a forum for discussions on vehicle models and possible configurations for Apollo. The committee's conclusions, or lack of conclusions, reflected compromises and conflicting opinions. After 3 months of intensive study of numerous vehicle combinations and mission approaches, the question of the launch vehicle for Apollo was still unresolved. On November 16th, Webb and McNamara reviewed the areas explored by Golovin's group and made several policy decisions. They agreed to halt the development of large solid rocket motors as a backup for the F1 liquid engine, although the Defense Department would continue to carry out advanced state-of-the-art technical development in the solid field. And they decided that the Saturn C-4 should be developed for the rendezvous approach to Apollo. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange Donate button or the Patreon link. Thanks.